continuing where we left off last day, I have to re-enter my data because my calculator resets itself, so I'm going to go menu to stat. You might have the points here still. If you were away, we're going to type in list 1 the x values. Now, to get there, for those of you that were away, you're going to go menu. And now we're in the stats menu. This is where you can enter points. Those of you that were here Friday, shush and bear with me. And we're going to type 95, 79, 68, 38, 27. Those are the x coordinates that they've given me. And for the y coordinates, and I know that they want those as the y coordinates because there's the letter y right there, I'm going to go 425 goes opposite the 95, 1950, 3191, 8000, and 10824. So if you have those already in, look up. And if you're typing those in, look up when you're done. But please type those in. You got those typed in already, Chelsea? Nope. Okay. If you need help figuring out how to type them in, because some of you were away, I can help you, but it's in the stats menu. Oh, and you may, for those of you that were away, you may have found some previous points. Again, to delete stuff, if you look up, it was F6 arrow sideways, and then F4 was delete all. Yes. And then arrow sideways to get back to the menu here. And then once you've got them typed in, you all have a F1, a graph menu still, is that right? So a good habit to get into is to try going graph, and then graph it as graph 1. So F1, F1, it gives you a shape. Did it give you a shape that looks like mine? Can you try that? Graph F1, F1? Because, Mackenzie, what you're going to have to do eventually is figure out what it looks like and tell it, try that graph. In other words, look up, if I had one that went like this, I'd think maybe it's a parabola. And I'd tell it, try fitting a parabola. If it looked completely straight, I'd say maybe it's a straight line, try fitting a straight line to it. If I had one that did this, up and down, you don't know yet, but I would say that's a trig function, try fitting a sine graph to it. If I had one that we're going to have more in our pocket by the end of the year. Everybody there? Then let's do some calculating. What will I hit to do some calculating? F1. F1. On the previous menu, it's F2. And the question has told me that it wants me to do this as a logarithmic function, So I'm going to go not fit at that, no, arrow sideways, F6. And I'm going to say maybe it's a logarithmic function. And then some of your calculators might have more than one option, or does another menu come up for you guys or no? So all of you should be on a screen that looks like this. Okay? Anybody not there? Now is the time to tell me. As a review, for those of you that were here, as a brand new for those of you that weren't here, anytime you do a regression on a graphing calculator, look up please, look up please, look up please. I'm talking to the back row there, look up. It'll show you the template for your equation right there. And it'll say A plus B ln x, and then it'll tell you what A and B are. So the equation is going to be 38,067 plus negative 8,260. Would I keep that a 5 or would I round that up to a 6? 6 ln x. That's where this equation in our notes came from. And then, Julia, you were away. This R value here, okay? The closer it is to +1 or -1, the better your data, the more accurate the equation. The fact that we have an R value of -0.999999, if you were doing research, say in pharmaceuticals, if you were a medical company and this was a cancer drug, you would sell your mortgage, your house, you would buy shares because you're going to be a billionaire. You found a medical drug that has a 1-to-1 cure rate. Most medical drugs have an R value of about 0.2. or 0.3, and that's enough to be, holy smokes, this makes a difference. If your R value is close to 0, what that's saying is, you know what, there's no relation that I can find between your X value and your Y value. It's random data. If it was medicine, the drug had no effect. Okay. So we'll be cooking the data. Carson will be making up values. Our R values will be unrealistically high. Okay? So can you, if you haven't already, write this equation in your textbook, please, under Part B. And then here is where we ran into some problems between my virtual TI, my virtual calculator, and the new calculators and the old calculators. Do the new calculators have a copy option on your screen? So for the new calculators, if you hit copy, which for me is F5, what is it for you guys? F5, and then hit enter or execute. It'll store that equation automatically in Y1 on the graph menu. For the old guys, sorry, copy, and then if you hit execute, and if you now go to your graph menu, which for me is graph 5, option, what option is it for you guys? 3? Does it have that equation under Y1? Okay? That's a huge time saver, because otherwise, by the way, it's also nice because it carried all the extra decimals, which is much more accurate as opposed to my rounded off one. Now, anytime you go into the Y equals the graph menu, after you've copied an equation, there is one thing you're going to have to do. Can you all look up? You'll notice the equal sign here is not highlighted. This equation is deselected. First thing you're going to have to do is hit F1 to select it, to toggle that equation on. Otherwise, if you try and graph, you're going to get an error because it's saying, I don't have an equation to graph because you didn't turn that equation on. Now we need to pick view windows. My graphing calculator, by default, tends to pick a half-decent window. Apparently, we found last class, yours does not. So you ready? Let's go view window. Okay? You may have some data there, but we're going to fix it anyways. Where did I say we almost always wanted to have our minimum? Where have we started every time? 0. Let's go x min 0. What's x measuring according to this question? So look at the chart. What's it measuring? What's the biggest percent you can get? Let's go from 0 to 100. Okay? Now, scale, going up by 1s would be a bit yucky. How about by 10s? That's a nice scale. Y min, 0. What's y measuring? Now, age in years, the biggest age that appears in my data is 10,000. Scan the questions. Is there an age that appears bigger in Part B or Part C? Okay, now, what's the smallest percentage that appears in the questions? Not in the data, in the questions. 20.3. So if I'm looking at my data, I notice 27% is 10,800 years. If I want to fit, what was it, 20.3? Yeah. How much further do you think I should go? Best guess. Okay, Jake says, let's try an X max of 15,000. What would a good scale to go up from 0 to 15,000 be? Go up by 5,000? Sure. Now I'm going to draw. Certainly that does look like a either exponential decay or actually this is a logarithmic graph. Okay? Now we're going to try and answer the questions. So now it's just like 2 lessons ago. Logan, now that we have our equation, they're probably going to give us half a data point and we're going to fill it in. They're either going to give us an x value, we're going to do a y calculation, or they're going to give us a y value, we're going to do an x calculation. So I've written down the equation for Part B, but I'm going to keep the more accurate one. Let me pause. So it says on a graphing calculator, display the graph of the regression equation in B over the scatter plot in A. That's trickier to do on ours. You know what? We got the actual graph. Good enough. I've done part C. Okay? Maybe, could I go menu, stat, and... yeah, I don't know how to get the actual line to appear over the data. There probably is a way, but I'm not going to muck around with it. Instead, let's answer the questions. So D, part I. A bone fragment, blah, 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 blah. Here's what I see. They gave me 20.3%. Is that an X value or a Y value? Look at the chart. An X value. What do they want me to find, Grayson? They said estimate the age. A Y value. You know what? They want me to do a Y cal. Okay. So I'm going to go here. Oh, no, I'm going to go to my graph menu, which for me is here, draw. And I'm going to go, how do I do anything in a graph? G-solve. Arrow sideways. I want to do a Y calculation for 0.3%. Good guess, by the way, Jake. Now, if we had guessed 12,000 instead of 15,000, we would have got an error. It would have said, I can't find it. We would have just had to move our graph over more. Okay? 13, what does it say? To the nearest 1,000 years, we can say, you know what? That bone fragment is around 13,000 years old. Darian, I would have an issue if you tried to convince me that it was 13,182, because I know in carbon dating there's some leeway. But you could certainly convince me that it's more than 10,000, less than 20,000. There I'd be able to put money on it. And you know what? I'd probably let you tell me, yeah, it's between 11 and 15,000 years old. 13 or so. Part 2. What's part 2 asking me to find? Percentage. Okay. That means they're going to, percentage, that's an X calculation. They better have given me an age, did they? Mm-hmm. Okay. So I'm going to go G-solve, X calculation. When the age is 10,000 years old, I got 29 point, to the nearest whole number, 30%. I would expect to find 30% of the carbon of the carbon-14 to be remaining. Part 3 says, compare to the previous lesson. We actually did this question where they gave me the equation. This time we got it from the data. We're going to do a couple more. Look up. I don't have this written out for you, but I'll make this nice and big, I think. Okay. Here is a graph where we have, I can make this a little bit bigger even, percent charge and time t. Let's try putting this as X and this as Y. So let's go into our stat menu, clear whatever data that you have, and I'm going to move mine right to the middle so you can see both. How do you delete? Remember that was F6, F4, yes, F4, yes, and then don't forget to hit F6 to get your calc menu back. Giancarlo, you want to give me a little elbow for me? Thank you, sir. Follow along, please. So, in the X column, I have 100, 90.26, 73.9, 60.51. Is that big enough? Mark, can you see at the back there? Have I got the font big enough or not? Yeah? 49.54. 40.56. And in Y, I have 0, 0.01, 0.03, 0.05, 0.07, 0.09. And when you're done typing those in, it says construct a scatter plot. So go graph, F1, F1. You get something like that? Okay. It does look a little curvy. In fact, it looks either exponential or logarithmic. You looking okay, Dom, or not? So go check a typo. By the way, if your graph looks wonky, there's a typo. You might be able to figure out which point it is by looking at which one doesn't fit in. Is that okay, Rachel? Okay, you're back? Okay. Now what? Let's do a calculation. Click. I'm going to gamble. I'm going to suggest that this is a logarithmic because it kind of looks very much like the graph we just did. So I'm going to go log. How's my guess? Pretty good. I got an R value of negative 0.999. By the way, the negative is telling me it's a decay or a getting smaller. So here's what it's saying. The equation would be y equals 0.496 that plus negative 0.09999 that. ln x. You know what? Let's copy it and hit execute to store it. Let's go into the graph menu. I'm going too fast? You've copied it? Don't forget to select it, turn it on, otherwise you won't get anything. Yep, let me pause. Go into view window. X min, probably 0. What are we measuring in our X column? Well, percent, what's the biggest percent I can get? Okay. Scale, actually 10 works nicely. I happen to have a 10 that appeared there. Y min, 0. The biggest Y value I get is 0.09. Now, I'm going to look and see... you know what? It says construct a logarithmic model, and then it wants the T5 flash duration. What is the T5 flat? Whoop. Oh, then it wants us to analyze it for 50% of its initial charge. It says that's the T5 flash duration. Okay, so we've got our graph. I think I'm going to go to 0.12. Scale. Do I want to go up by 5,000s? No. You know what? I think going from 0 to 0.12, 0.03. In other words, if I was going from 0 to 12, I'd go up by 3s. 0 to 0.12, I'll go up by 0.03s. I hit graph. We should get, hey, that looks okay. Yep. Yep. Hang on. Okay. Did you select the graph? What's the error? Can you read it to me? So, did you remember to turn the graph on? Okay, this question wants 50%. 50%, is that an X value or a Y value? This is an X value, so we're going to do a Y calculation. So I'm going to go G solve, arrow sideways, Y calc when X is 50%. Apparently that happens after 0.069 seconds. This is some capacitor camera flash thing I found online and just cut and pasted it. Okay. Let's try one more, I think. Okay. So, this is days and height. This is corn. Corn grows quickly, really fast, but as it gets taller, it doesn't grow as fast. It's exponential. So clear your data. Let's make days the X value, and let's make height the Y value. I'm going to go right to here. And I think I can go like this, Mr. Dueck. There we go. So menu, make sure you're in the stat menu. Arrow sideways, delete all. Delete all. 8, 14, 22, 40, 48, 54. 4, 18, 48, 60, 71, 73. Now, who's got the old calculators? Okay, Zach, here's what I've noticed. I found this out with Logan's machine. If you go straight to calc, the copy feature doesn't appear. If you hit graph first, F1, F1, and now go to calc, then the copy feature appears. I don't know why, but okay. This is a logarithmic as well, because Matt, remember what all the exponential, that doesn't look like an exponential, it looks like a flipped or weird. This is logarithmic. So I'm going to go arrow sideways, logarithmic. For me, it's F2. I think for you guys, it's F1 or something like that. And here's my equation. The y equals, I guess, days equals negative 74.38 plus 37.2 times the ln of height. Or no, height, that's our y value. H equals that times days. Okay. I'm going to copy. Enter. Yep.
You can go back, just click exit, go back to the graph, just for a second. No,
Maybe.
oh, okay, never mind.
Okay. I'm going to go back to actual graph because I've copied it. Change my view window. 0. X is days. The highest number of days on this question is 54. What would be a nice number, a little bit bigger than 54? 60? Scale, actually 10 works. Y is height, 0. Maximum height that appears here, actually, you know what? It wants me to go from 0 to 100 days, so I'm going to go back up here, and my x max is going to be a 100, because it says go from 0 to 100 for my x's. Okay. Height. The maximum height that shows up is 73. You know what? I'm going to go from 0 to 100 here as well, because I'm not sure exactly how high this corn is going to grow. And let's graph, see what this looks like. Thank you. I would have forgotten to select it. From 0 to 100, Darian, I usually go by tens.
Makes sense.
Okay. You get a... Okay. And again, Brianna, what this is saying is, first of all, it takes a couple of days for the corn to get out from underneath the ground. That's why there's an initial height of below 0. It's underground. But when it starts, grows fast. But as it gets bigger, it doesn't grow as fast. It's leveling off. Okay. What do they want me to ask or answer here? It says corn develops tassels when it reaches a height of 4 feet, which is 48 inches. To the nearest day, when will the corn... Guys? Anybody not there? I should ask, sorry. To the nearest day, when will it get tassels? So 4 feet is 48 inches. Inches, was that, you know what? That's a y value. They want me to find an x value. That's going to be an x calculation. When y is 48 inches, 4 feet. Apparently, after about 27 days, roughly a month in, well, 4 weeks in, that's when you should expect to see the corn getting the furry part on the top. Okay. What else can I ask? Oh, according to your model, on what day did the corn germinate or emerge from the ground? I think right there. How can I find that? G-solve. What did I call the x-intercept? Root. Ironic for corn. Can't see it on mine.
It's a 7.
It's a 7? By the way, the other way that I could do it is if I'm on the x-axis, how high am I? 0. You could actually go x calculation with a y of 0. That'll also give you the same value. So if you're clever, there's all sorts of workarounds. Okay? What's your homework? I'm going to be checking lessons 1, 2, 3, and 4 today. Number 1, when it says represent the data, just do a sketch. Then, for part B, is it exponential or logarithmic? And then perform the appropriate regression. Now, here's the problem. Our calculators are going to go y equals AE to the BX. And so your answers in the back won't look the same as the answers you're getting. You might have to check with a neighbor. But you can certainly use those equations to figure the value of y when x is 7, to figure the value of x when y is 27 for all 3 of these. By the way, I would do, once you've entered data set 1, I would answer all of part B. In fact, what I would do is I would divide this into 3 sections for set 1, set 2, and set 3. Do all of it for set 1. Don't retype this data all the time. So number 1, 2 is fair game. 3 is fair game, only again, instead of getting P equals AB to the Y, you're going to get P equals AE to the BY. Okay. Some of your calculators might be able to do base B, but the older ones and mine can only do base E. So, okay. But you'll still get the same answers for part B and part C. Number 4, but again, it's going to be T equals AE to the BY. You can skip part C if you want, although if you want to see how accurate this is, you can. Five is good. 6 is good. And I'm also going to be checking lesson 1, 2, 3, and 4.